How's it going? This little video is the last for the day because I'm getting tired. But anyway, we're still in EIGRP, and what I've done is modified this network a little bit, and I've changed the clock rates. So 128 kilobits per second on this path, 500 down this path, and 500 down that path. Now that should change our routing tables. So let's just have a look at these clock rates. So on router 2, if you do a show run, if you remember, the clock rate is given on the CCENT side. Not too sure if I've covered that. I think I did, but anyway, if not, so this serial 000. It's normally Telstra or Optus's hardware that actually gives us the clock, but in our case we're simulating a WAN, so we put a clock rate on the CCENT. So 500,000 and 500,000 there. On router 1, I've already got it up, 128,000 bits per second on that interface as well. So we've got different speeds running across this network, and our routing table should show this, but it doesn't, because the speed to get to this network, the best path is actually clearly up this way, because that's quicker from router 1 to router 2 into the 10.004. So if we show IP route and open it up a bit, we've still got equal cost paths. So when we work out the metric for EIGRP, we're actually using the lowest bandwidth on the whole path. So this one says it's 500k and this one says it's 128k is the bandwidths of the interfaces. And then the sum of delays, I don't know if you remember that one, so that interface's delay and that interface's delay would be added together and chucked into the calculation, and off we go. So they're still the same, even though the clock rates, as we've seen, are actually different. Now that is because interfaces, let's go on to this interface here, the actual bandwidth has not changed. The bandwidth of a serial interface is always 1.544 kilobits, and it's just a value that we put into the system. We need to go in and change these values across our network to actually replicate the speed of the links. While we're in here, these are the metrics that EIGRP uses to actually calculate the feasible distance, the actual cost metric. The two that are used by default is delay and bandwidth. Now we can use, if you want to, reliability and load, and this one has transmission load and receive load. They are enabled by modifying the K values just quietly, so I'll just show you those. So if we show controllers, for our serial, that's showing us our DCEN side. It's not the one I wanted to do. Lucky I know my stuff, eh? Show IP protocols is the actual one we wanted, and that's the metric weights, so the K values. So K1 says use bandwidth because it's got a 1 there. K2 has got a 0, so don't use reliability. K3 has a 1, so use delay. K4 has a 0, so don't use load. And K5 is another value. It's actually not one of these. Go figure. Okay, so all we need to know is that we need to change the bandwidth of our links to actually get ourselves a better feel for what our network is actually doing. Okay, so on router 1 I need to change the bandwidths of these interfaces and on router 2 and on router 3. I need to change them all so that they all replicate the actual speed of the link. So let's go in there. So conft, so interface serial 000, and it's as simple as just typing in bandwidth, and if you put a question mark there, it says the bandwidth in kilobits per second. Now my clock rate is 128. Oops, yeah, I've just done it wrong. 128,000 kilobits per second. And because we've initiated a change, then dual will drop out and come up. So we need to change the other side up here. But let's, while we're on there, let's go on to our serial 001, and our bandwidth is going to be 500 for that one, and that's that one done. So let's go back up to router 2. T. So interface serial 000. Bandwidth is going to be 500. Serial 001. Bandwidth is also going to be 500. And we'll go to router 3. Interface serial 000. Bandwidth there. Now which one is 000? I think it's the bottom one. Let's put our mouse over here. So yep, it is. Is 128. And for our serial 001, our bandwidth is going to be 500. There you go. So in order to change the bandwidth and change the way that this network reacts, let's have a look now. So if we show IP route, we can see that now to get to this network here, we've only got one path on our final routing table, and that value there's changed as well. Not too sure what it was before. I don't think we've got it up here. Yes, we do. Awesome. So 2681856 were the two values. Now that was using a 1.544 meg link, which was actually a T1 link. Now we're using a 500 meg link. It's a higher cost, but it's still a better cost than the other path. Do we still see the other path? Well, let's have a look. Show IP EIGRP topology. And yes, we do. So in here, to get to the 10.004 network, we've got one successor, which is one path in our routing table, so that says it there, one successor. Its feasible distance is 6144000, so that's the metric cost in there. And if we go via 10.001, which is up that path there from router 1 to router 2, then that's our metric. So that value there is 6 million odd, is the value that's worked out. This value here is the advertised distance from router 2. So that's its cost to get to this network. So it advertises out that value there, and it's worked out that. If we go via 10.009, which is the second path, which is down here, this value is the advertised distance of router 3, and it should be the same as router 2 because they're both on a 500 kilobits per second link, and they are the same values. Now because this value is lower than that value, we've actually met a thing called the feasibility condition, and that's to prevent routing loops happening across EIGRP. So that's nice to know and painful to think about sometimes. But anyway, that's the advertised distance out of router 3, and this is the feasible distance via this path to get to that network. So we've got a backup path, and the backup path is called a feasible successor. So this is a feasible successor in EIGRP world. So that's good, and we've got a couple of feasible successors down there for different networks as well. So we've got more of an interest in our table there. And that's it for bandwidth. Actually, we've played around a bit, changed some speeds. Just remember the bandwidth of particularly the serial links is always going to be 1.544 meg or 1544K. The fast Ethernet and gigabit Ethernet will take their bandwidth from the actual speeds of the link. So gigabit is 1,000,000, fast Ethernet is 100 meg. So modifying at least your serials to replicate the actual clock rate on your network gives you a better feel for where traffic can go across your network through there. And that's it. All good. Thank you very much.